right, welcome ladies and gentlemen to another not so very entertaining but very educational video from Mr. Ewert's class. As you can tell from my Bane from Batman look, it is the 2020-2021 school year, or at least I hope that is the case, because if we're still doing this 2 years from now, I don't know, I'm out, I gotta retire. But otherwise, this is why we're all wearing masks, which is okay, because, you know, we all look beautiful in masks. So let's get on to today's lesson. We're going to look at the volume of certain solids. We've talked about surface area, and surface area is actually, in my opinion, harder because volume, you just have to follow the formula and get her done. So let's take a look at volume of prisms. It's 4.5, 4.6 in our textbook. If you're in our class, you should have this with you if you're watching this video. If you're not in our class, then you're just benefiting. And I'll pause the video for a moment. Just paused it there for a quick interruption. All right, so volume of a right rectangular prism. So first off, grade 8s, grab your show me boards real fast. I'm going to give you your first one. I just want one number on your board, unless you think you know how to write the math sentence that got you there. I would like to know the volume of this shape right here in front of us. And by volume, I mean how many cubed centimeters. So these are centimeter cubes. So like this one here would be 1 centimeter by 1 centimeter by 1 centimeter. How many cubes do you think are being used to make up this rectangular prism? So we're going to presume that all the cubes in the back you can't see actually exist. I already see a number 50 going on here. Now, just to outline it for you, I see we've got 1, 2, 3, 4, 5, 6, 7 right here. It's 2 tall and 4 deep. So we've got 7 by 2 by 4. 7 by 2 by 4. Now, if you were doing just a rectangle of this, let's just look at it as a rectangle, and then we'll get to your show me boards. We took a full screen snip. Loving this full screen snip option. So let's just draw this. I'm just going to draw the top part if we were just looking at the top part. And when you were a kid in grade 3, you probably learned multiplication like this. So let's say it's 1, 2, 7. Okay, right. 1, 2, 3, 4, 5, 6, 7, and it's 4y. And when you were a little kid, you probably said, I know how many there are in there, teacher. Oh, just a minute, I have to tie my shoe. Just a second. I have a cat. I'm just kidding. You know how kids in grade 3 are. I shouldn't say that. I have my own kids in those grades. But you probably got around saying, there are 1 group of 7, 2 groups of 7, 3 groups of 7, 4 groups of 7. So you probably went like this. Does that make sense to you so far? All right. So now that we've established that there's 28 in the top, you can probably imagine if this was all just one layer thick, it would be 28. But we got 2 layers. We got 2 slices of bread in this loaf. Now, another way you can think about it is you can do it this way. Oh, where are my tools here? I've lost my tools. Oh, there we go. Another way you can think of it is this. Oh, this eraser is very fine. That's very frustrating. You can also think of it this. I could find this face. That's 2 times 4. So I've got 8 centimeters across here. But how many slices of 8? So if I took all of this, that's a total of 8 centimeters cubed. But I have 1 slice, 2 slice, 3, 4, 5, 6, 7 slices of 8. All right, let's get those show me boards. How many cubes do I have here? I see 56. I see 56 again. I see very small print that I can't read. I see 56 again. I see very small print I can't read because I can't wear my glasses because of my mask. I see 56. I must have some smart cookies in here. All right. Volume. I need a formula now. What do you think our formula is going to be for this? Yes, Henry. Length times height times depth, like that? Ah, I agree, because then we would go this times that, right? Aha! But usually we would have length times width times depth like that. So there we go. We've got 3 dimensions. So let's do a quick example. We're going to run over to our whiteboard, and I'm going to give you another shape for you to do. All right, here we go. Let's move it over. Here is your shape. All right, so here is your shape. Looks kind of like a Rubik's Cube, except it would have to be 4 by 4 by 4 to be proper, or 3 by 3 by 3. But this one appears to be 4 by 4 by 3. So give me first, we're going to start with your volume is your length times your width times your depth or height. Wait, I guess I should say length, height, and depth, sorry. Length, height, and depth. So there we go. Start yourself with a formula and then enter your numbers. So what do you got? I see it's 4 by 4 by 3. Thank you very much. I agree with you. Very well done. Pretty easy peasy, lemon squeezy. I agree with what I see there. I like your formula. Very well done. Can I see one more before we go? Who's going to be the third? Who's third in? Very nicely done. So my volume, my length across the top here seems to be 4. And my height seems to be 1, 2, 3, 4. And my depth appears to be 3. So that's 16 times 3, which equals 48. But wait, centimeters cubed. You got, hey, cubed. Do not forget that 3. It's very important. Why 3? Why 3? Now, hold on. I'm going to show you. Well, 1, we're in 3 dimensions. But here we go. I'm going to show you there's 4. Then there's 4 squared. Then there's 4 cubed. Okay, here we go. This is 4. 1, 2, 3, 4. Make sense so far? All right. This is 4 squared. Two dimensions. Then there's 4 cubed. You are in 3 dimensions. And it gets so pretty when I'm fast. There you go. And if it gets any messier, it's just a plate of dried spaghetti. There you go. So 3 for 3 dimensions, because you're going 3 different. You've got your length, your height, and your depth. So that pretty much is like the entire lesson that you need to know for this one. This week we are doing a double lesson, and that's because, like, seriously, this one's easy peasy. You just got to think about it like this. I got a box, and I'm filling the box with bricks. How many bricks can fill the box? And the bricks are all centimeter cubed. Now, the way this thing is going to mess with you, though, is sometimes it's going to give you fractions, okay? So it might have like a fraction of a centimeter and see how many whole bricks you can get in there. So let's go look at one place where it's going to give you a bit of a curveball. Come on, it's got to have a brick here about this. No. Does the truck one have the, like, how many boxes of certain size can sit in there? No. All right, well, you know what? We'll cross that when we get there, just because I know it's going to try it at least once. Well, we'll see. But in the